Swayam Prabha. Digital India. Educated India.
So as I said, Honeywell's business markets are mostly on the Europe and US. This European Green Deal, they want their country to be carbon neutral, net zero. So whatever the manufacturers do business there have to comply with the regulations there. We need to provide certain certifications on sustainability so that only we'll be able to market the products there. So with this motto, we started this Center of Excellence at Madurai. We work with the supply chains in different countries like Europe or US. We try to get the engineering data from the team, manufacturing data, and do assessments on life cycle assessments, carbon, and then claims and whatever the engineering team wanted to do. And we do that in our Madurai using the softwares and other things. And we provide back. And some of the products need some third-party verification because self-declaration is not acceptable everywhere because of greenwashing and other constraints. So we do some products which are high runners, go for third-party verification, and then we provide that certifications. So as you know this, I'm going to talk about this EPD, which is a third-party verified environmental product declaration, which covers the entire life cycle of the product, starting from raw materials to the end of life, the environmental profile. So it not only includes the global warming potential, it also includes many environmental indicators like 28 plus indicators we are declaring for the product entire life cycle. And the certificate is third-party verified and it is valid for 5 years. So after 5 years, we need to again renew it. So that is a process. So apart from life cycle perspective, our Center of Excellence, we do projects on product stewardship. So mostly in the US countries, they have this chemical regulation compliance. So they have to comply with REACH. So REACH stands for registration. There are certain chemicals present in the material of the product. So those chemicals should be compliant within the limit of that norms given by the government. So the product stewardship team collect those informations from the suppliers. We do the check of the compliance and then we provide it back. So that is the another vertical of that we are doing on product stewardship. So if you take US, we have this California Prop 65 compliance. And if you take Europe, we have REACH and ROSH. So these are the regulations which will target on mutagenic, carcinogenic, heavy metals, lead, cadmium, chromium. So those compounds in the product, we have to check with the check with the vendor or the supplier of the product and provide that certifications to the industry. And the third vertical we are doing is on ESG. So as a corporate, we have to publish this impact profile or ESG report every year, like how much we are aligning to the ESG goals of the company. So it was also like we defined our SBTI targets and to become carbon neutral by 2035. So to aligning to that, we have the 5-year plan, 3-year plan. So the ESG team is collecting all the scope 1, scope 2, and scope 3 emissions of the entire factories of Honeywell. So you see, Honeywell factories are more than 500 plus surrounded all globally. And there are regulations on global things also, like we have to comply with that. So we collect data from scope 1, scope 2, and scope 3 emissions. Scope 3, you know, it's very difficult because it's from the supply chain. Getting informations it's also very difficult. So there are 14 categories in scope 3, whereas we are just doing like 6 or 7 categories. So whichever in our scope. And then, so that's what we are doing in ESG. In addition to that, we have CSRD and TCFD. These are the other two regulations or frameworks in ESG, which is our voluntary basis. So that also we are complying with that. So this is the overall Center of Excellence of Sustainability. So we know that I already told there is a market demanding on the compliance part because that's only all this OEM or manufacturing going behind the sustainability on preparing this documentation, other things. So there is market competitions also, like competitors are able to do and we should also do that. Then only our product will be selling in the market. And there are regulations coming up like construction product regulation, eco design for sustainable product regulation. So mostly on the DPP part and eco design have to be covered by that regulation. And then EU taxonomy. So EU taxonomy is on the all the products which are ESG compliant. If we need that certifications to be given to the uh, country, like when we do some business or any export or import of materials in that Europe region. So all these things are coming up, and also we should not get trapped into the greenwashing also. We need a scientific background to prove our data. So that's what this life cycle assessment is taking care of. And also to comply with the organizational carbon neutrality targets and SBTi targets. So we are working on that. So as I already told, there are three verticals, which is the product stewardship. So complying to the REACH, ROSH, and TASCAS regulation, depending on the country. And then core PSG service, where we do the CDP and TCFD framework, which is a voluntary compliance on scope 1, scope 2, scope 3 emissions we are doing. And then EU taxonomy is coming up in another 2 years. And then third vertical is life cycle assessment, where we do self-declarations, eco-labels, EPD, and product carbon footprints. And the fourth one is like we are into the journey of the circularity because it's very highly a new topic. So now we established our team on life cycle assessment. Now the next year's prolonged plan would be on circularity and doing some eco designs and other things into practice. So as we know that Honeywell is on to 4 businesses. One is on the building automation products, mostly on the fire panels, fire alarms, detectors, controllers for the HVAC systems. Yeah, sensor business in industrial automation. And also we have a chemical business where low carbon refrigerants and adsorbents, catalyst. So these are also will be developed. That is in Gurgaon factory. And we have the another one, which is everybody knows, which is the aerospace industry. So all the aerospace AHUs and then engines. So all this business. And also the major thing is on the software part. So we sell as a package with the software along with the hardware that work together along with servicing and other things. So they sell as a package. So this is Honeywell's business. So all our products needs EPD or some kind of environmental declarations to be compliant with the regulations. So that's what we pitch in. And I'm working for the building automation products. So when I say building, most of the buildings are becoming greener, LEED certified or any green building certifications. So once they go for this, they want the entire building carbon footprint number, including the products they use, including the building materials they use. So they try to reach to the vendors or suppliers to get that number. So Honeywell supplies all these fire panels, fire products, alarms, controllers, HVAC units. So which is our scope. So as a result, we need to provide this EPD certifications to the industry for the LEED certification. So LEED, BREEAM, LBC, zero carbon, these are some of the certifications in different, like LEED is a globally one, DGNB is more German specific, and BREEAM is UK specific. So these are green building certifications which need EPD or life cycle assessment or something on REACH and ROSH, which is the chemical compliance certificate, and also on the recycled content, the pre and the post consumer recycled material present in the product. So this certifications adds value to their green building credits. So for example, if I have an EPD, I get 2 points in LEED certification. So that will add up to the overall green rating of the building. So our typical approaches is like, first we start with, because all our products are, for example, building alone have 44,000 products in our scope. So we can't do for each and every product. So what we do is, if there is a bulk number, it's like a small color change, will they consider it as a different product. So they call it as SKU, which is stock keeping unit. Every product will have a number. Even a small color change also, they will change the number, but the product is same. So likewise, if there is a bulk recruitment, we go for this revenue based PCF, which is on the scope 1, scope 2 emissions of our company allocated to the revenue of that particular business. So we prepared this tool internally, and it's for the internal circulation, not third party verified. Only the scope 1, scope 2 emissions and scope 3 emissions, certain categories, we verify with a third party. We use that value and allocate according to the business of our particular SBG. I said already 4 business we have. So we know the revenue for each business, we allocate with that revenue. So that is the revenue based PCF tool, which is a very quicker method, and the results are not very robust. So it will give you an estimate, not the correct one. The second one is the CIPSE TM65 basic. So CIPSE stands for Chartered Engineers for Building Service Engineering, Chartered Institute for Building Service Engineering. So this chartered engineers in UK and London, because most of the building products are in Europe as well as in UK. So this tool, it's a easy Excel based tool where we need to input the raw materials, transportation and other product weight and other data. It will give you a product carbon footprint number in a fraction of a second. That tool I will discuss in detail. So it will have 2 versions, basic and mid-level. It's a fast way of doing assessment. The next step we go for is a LCA, which is time consuming as well as it needs a lot of data, which we need to contact to the engineering team, supply chain, and then also on the downstream. So we need the entire data for the life cycle. So it is a time consuming one. So we take for certain products. Next is the type 2. So outcome of that LCA would be of a self declaration, which is a type 2 eco label, or it will be an EPD, which is a type 3 eco label, which is a third party verified one. So doing LCA alone is like, it's like telling our own. So, but if we do for a third party verification, you'll add value for your market competition or other things. So these are the various assessments we do depending upon the product value and the time and the money that comes in for this assessments. These are again. So apart from the 5 things, we also do on end of life instructions, life expectancy of the product. Certain projects, they are asking for end of life instructions alone, which means that how to dispose this product after the use. So they want that certifications. So that we will do. So this is on our future scope. Some products, they need operational energy, or so these are other things which is coming up as per the EU taxonomy. So I told PCF tool, it's purely based on scope 1, scope 2 and scope 3 emissions. Scope 3 also only on the upstream part, that is on the purchased goods and other things. So it is an internal tool we developed in order to manage the bulk request. See, if you see for a building of say 20 stories, you will have lot of building products into it. For every 10 feet, you have a fire detector, you have alarms, you have sprinkler, you have lightings. So all these products are Honeywell. We can't do for each and every product, collect so much of data, do the analysis. So for the fast assessment, we do this PCF tool, which is a product carbon footprint tool based on scope emissions. And it's completely an internal one. And you could see that for an example product, it is something around like actual LCA value is 2.16 kg CO2, and we have something around 2.26. But it is not like same for all the cases. So it can give you a range of that PCF value. So that is the thing. This because some of our customers are asking this, like we sell for some other companies and we are vendors for some other companies. They wanted it very immediate, these values. So we run this PCF tool and provide the data. And so these are the various assessments I told. And you can see the geography of that. PCF is mostly on the Europe, including UK we do. RC is on the global basis and others are on global basis. And see the typical time. For PCF, it takes only 2 weeks. And for recycled content calculation, it takes 2 weeks. And for EIP, so EIP is our own terminology, which is called environmental impact profile, which is nothing but an LCA. Outcome is represented for a customer in our own way. The LCA, just the LCA report is given in a different way of how Honeywell wants to declare it. So it's a self-declaration. There is no third-party verification. And it takes around like 4 to 6 months. And if it is an EPD, it takes around like 6 to 9 months, because we do LCA, we submit to the verifier. Verifier takes another 3 months or 4 months, and back and forth, and then it gets published in an eco portal or some common manufacturer's website. So thinking in mind which to act what, we will take whatever is convenient. So currently the markets, they are expecting a PCF number only, that is a product carbon footprint or a global warming potential. So not much onto the EPD thing. Like once a competitor has that, Honey will go for that. It's not a, because it needs money also. One EPD verification takes around like 400 euros. So close to 4 lakhs. And for every product, we can't spend that much money from the business side. So we have some shortcuts also to do that. So if we have, say, 50 products, and so how the EPD can be done, because we can't offer that much money, no? So grouping and other things can be done in EPD. That I'll talk back. So the first tool I told is PCF, based on revenue calculator, which is very easy, and based on scope emissions. So this is a little bit more onto the embodied carbon calculator. I told SIPSI is a chartered institution for building service engineers. So most of the building service products like pumps, boilers, controllers, lightings, whatever which goes into the building as a part of electrical electronic, not only that, timber, steel, everything which is goes into the building as a part of a product, can use this tool. This tool is more specific for Europe and UK. Since Honeywell based on US and sorry Europe, we prefer this tool much faster, because it calculates the embodied carbon of the material, and then it doesn't take use phase into account, the embodied carbon of the material, and then transportation, and then disposal. So maintenance, it takes care. So except the use phase electricity, if it is an electrical product, it needs electricity for using. So that alone, it won't take into account. The remaining things are taken for the entire life cycle using this tool. This tool is very easy, like just input the thing and you get immediately the answer. I'll show you that. So the data is like, we need to define what is that material. We need to define what is the bill of material of the product. So every product is made up of certain many components. If you see this this laptop or something, it is made up of mostly many different part numbers, which is contributing to metals, plastics, electronics, and other categories. So the same tool will also do the same. It classifies, and we need to provide the proper input. It takes the embodied emission factors into account, and it tries to do. So for the end of life, they have a conservative approach in this tool, like taking 10% of the material gets recovered, like that some conservative assumptions are taken. And this tool is a very user friendly, and it's equivalent to EPD also. Many places they are accepting this tool based output for the EPD equivalence if there is no money and time available. So this is how the tool works. So you can see here, it takes the entire product into account, starting from raw material, transport to the factory, manufacturing. So you might have seen that there are 4 stages in LCA, which is goal and scope, life cycle inventory, interpretation, impact assessment, and interpretation. So goal and scope we define. So this is about the life cycle, starting the same 4 stages are divided into like product specific. So once we go for product specific, we need little more information on that. Like for example, A1 is the material, raw material extraction stage. So from the ore, how we extract the raw material. From the plastic pellets or pellets, how much we extract the raw material. So raw material, A2 is the raw material extracted and taken to the factory to manufacture that into a part. For example, from steel ore, we can't directly use the steel directly. We need to make it into a sheet or a rolls or something. So that transportation is taken care in A2. A3 is the manufacturing stage, how that product is manufactured into a final part. And A4 is the, once a part is manufactured, it is transported to the nearest distribution center. So Honeywell, like an MNC, we won't directly go to every customer and sell. We sell to the distributor will sell to the local vendors. So that transportation to the site. And A5 is the construction or installation. So the customer receives the product, he install in the building. So during building installation, there may be some energy like drilling, or some oiling or something which needs to be done. Some electricity may be used in certain case of products. So that is the A5 stage, and B stands for U stage. So now the product is installed in the building. It is in the use for us. Every product will have a service life. Say for example, fire detectors, you can take like 12 to 15 years. It can be a service life of that. So during that service life, what is the use, what is the maintenance, and what is the repair or replacement we did any parts during that 12 years of the lifetime, and refurbishment or any refurbishment we have done. So it is applicable for any products, even or window panels or whatever. We try to do some maintenance activity towards its entire life cycle. Say the life cycle for 50 years. So during 50 years, we may do every 5 years once the maintenance. So 10 times we do maintenance for that. So all those inventories should be accounted in that particular stage. That is what this EPD about. And then operation stage. So electrical products consume electricity, and some products may require water also during its operation, boilers and other things. So that is the operational energy. So this tool will not consider that into account, whereas the remaining life cycle stages. And C stands for end of life stage. So the product reaches the end of life of the service life. We need to dismantle the product. That is accounted in C1, which is deconstruction. And C2 stands for transport. So not like India, we just throw it in the dustbin. But in US and Europe and all, we can't just throw it, no? So we need to properly dismantle and transport to the nearest waste processing or a material recovery facility. We need to provide. That is a reason. That is a need for the customer. So that transportation distance, and then waste processing is nothing but a material recovery facility where they try to segregate the useful materials of that product and go for recycling and go for incineration and go for disposal. So that is a place where they try to dismantle the products and take the useful components and throw the remaining components. So the waste components like electronics and other things, they go for disposal, which is a landfill, mostly the landfill one. So that is C4 stage. And D is one special case here where, so this is the circularity part here. So we dismantle and in the waste processing, that is a material recovery facility in C3, we have some recycling materials in the product. We have some incineration materials, plastics and all will be incinerated. So incineration, what it will do? It will try to generate some electricity and it will try to replace the electricity in the grid. So we are taking a credit out of it. Rather than burning the another material, we are disposing the waste and using the replacement to the grid. So we are taking a credit for this much of material. And similarly, recycling. We recycle the steel into a useful steel material in the recycling facility, where this useful steel will eliminate the raw material extraction and transportation impacts. So we are taking credit of replacing that in the end of life. So as per this building regulations, all these credits or benefits which we are taking from the product should be reported separately as module D, and it should not include in the life cycle stages. This is because it will reduce your number. This will come as a negative value because you are taking a credit in the entire system. So if you try to include it, the life cycle number, it will reduce your carbon footprint number, which is not correct. So as per the building regulations, all this credit due to recycling, reuse, incineration should be accounted separately in a module D. So this is the entire life cycle. And in this tool, we won't consider the operational electricity and the operational water use in the product, whereas it takes care of the remaining things. So this is more or less accurate. So this is the calculator. This is a simple Excel spreadsheet. Anybody can download. It's downloadable also. So here we need to input what is the product type, whether it is a controller or whether it is a chiller or whether it's a HVAC system or lighting system. There are some specific product categories into building products. So we need to input that, and we need to define all the raw materials in the material extraction. So which means that if we see any one product, it is mostly made up of plastics, metals, some like electronics. If we see for electronic products, electronics and other things. So we take the product, we do a mass balance analysis of the parts, and then we come up with the percentages of everything we input in this tool. This, and also we should provide the location of the factory where it is located. So the nearest factory it will take into account based upon the Google Maps they have inbuilt in this tool, and we need to input the production number as well as electricity. This is because manufacturing phase, we need electricity for manufacturing the product. So how do we do that in industry? So every product we can't go and get in every product line, measure the electricity or through meters, we can't do it. So generally there comes this allocation into practice. You might have learned in your previous sessions, like allocation based on mass, allocation based on energy and other things. So, in our case, Honeywell will not manufacture every product on their own. So they try to procure parts like plastic parts from some vendor, electronic parts from some vendor, mechanical parts from some vendor. They do some IP into that thing, and they assemble into a final product. So during the assembly, there will be some wastages will happen due by soldering or something. So, but we have the entire factory electricity use, and we have the entire water use or wastewater use for the factory only. We can't do it for get the data for every product wise. In that case, we try to allocate based upon the numbers or the production volume. So we know that the yearly consumption of electricity for the factory per year, and we know the yearly production of that factory per year. We try to allocate based upon the number of the particular product. It may be an overcounting, but it's a conservative approach. Like rather than telling low, it's telling high is not a big thing, because it's very difficult. This is a challenge we face here, like getting what is electricity consumption for manufacturing of one laptop from one factory. It's very, very tough to get that value. If it is like a steel or something, we can generate because it's one product. Here is on mostly on assembly products and electronic products also. So this tool is a very rapid and fast tool. It's accepted equivalent to EPD in UK and Europe markets. So just a click of thing, if we input all these things, we get the product carbon footprint number. So next is the type of certification is recycled content. So recycled content, we have two kind of recycled material into the product. One is the pre-consumer recycled content, one is the post-consumer recycled content. So pre-consumer, which means that during the production line or during the assembly, there will be some waste generated. For example, if you are trying to drill some steel part or something, some scraps will be coming up. So if you try to use it within the same product, or if you try to collect that scrap and use in some other product, but within the same production factory, that is called pre-consumer, consumer recycled content. So this recycled content mostly comes for metals. If the product has more metals into it. Electronics, we don't have this recycled content. Plastics also, very few plastics we have. So mostly metals we will target here. So pre-consuming recycled content, getting that information is very difficult because assembly process wastage will be very less. And for that particular product, how much waste we get, that nobody can give that data. So we take this ISO 14021, so which is a standard, which is a type 2 eco label. So this eco label has claims for various categories. One is that recycled content. Similarly, we can do for energy efficient products or some toxic less products, like that 20 categories are there in this. So using that standard, we are going with the global recycling rates of the metals. So if you see an eco-invent database, it will have scrap value into the, if you take one raw material in SEMA-Pro, say for a steel, obviously it will have some scrap into it. Either it comes through blast furnace route or electric furnace route. So that scrap value we take into account and we try to calculate for the overall product. So, and the other recycled content is that post-consumer recycled content. So which means that once a product used, we dispose to the, finally we dispose. That is post-consumer. So every product will have some kind of recyclability or potential or recoverability potential in that product. If it is mostly made up of metal, it can be like 80% we can do the recovery rate of the product. So that value we take into account for the post-consumer recycled content. So it is completely a region specific. If you see Europe regions, it is high. If you see for India, it is very, very low. So it depends on the region specific only. So we are taking the global average for all the metals, particularly the metals we are targeting the recycled content. This recycled content certification, this is a certification. This is much used in all the building products. We get 1 credit point in LEED certification for this recycle declaration. So any of this LEED declarations. So this is how we call it a product. So K3498, this is one product. It's a SKU. We call it a stock keeping unit. So this product has this much pre and this much post, like that we declare. So this is about recycled content. The next we move on to the LCA. I think you know the basics. It's the entire life cycle environmental profile starting from raw material to end of life of the product, following ISO 40 and ISO 44 guidelines. So the process enablers is like we can identify the hotspots through this life cycle assessment, and we can compare our technology with the competitor using this life cycle number. And then we can also make our production much greener. Suppose our hotspots comes in manufacturing, we can suggest to the team to go for some renewable based things, or any raw material is contributing much emission, we can tell to an alternative material. That's what eco design is about. So we can do that using LCA. And for the product support, we get the EPD out of the LCA. So the outcome of the LCA will be documented in a certain format following ISO 14025 standard. So ISO 14025 is a standard by which the LCA results are documented in form of a environmental product declaration. Okay, so that is the outcome of that product specific LCAs. And then we can compare or compete with our competitors, and we can understand more onto the use phase and the end of life phase of the product, where we can think of circularity score for the product based upon the end of life cycle modeling. So it also avoids greenwashing because we have the scientific proofs and evidences to show whoever asks, like we did this assessment in this way, like that. So it's a widely accepted one. So goal and scope, life cycle inventory, impact assessment, interpretation, I think everybody knows. So here, more specific to life cycle impact assessment, there are various methods like recipes, Tracy, CML. So recipes is globally accepted, Tracy is US based. But if you go for a building products, we have to follow a methodology called EN 15804, which is based upon the environmental footprint 3.1. So environmental footprint 3.1 is a methodology that we have to use specifically for building products if we wanted to declare our life cycle number for building products. So this is a PCR. So before moving that, I think this and all, everybody knows cradle to gate and cradle to grave. So tools and indicators, I think GLP is the basic thing. In addition to that, acidification, other indicators, we have like 16 indicators mandatory to be given. And in addition to that, close to 28 indicators we have to declare in the EPD outcome. Okay, something on primary energy demand, hazardous waste, and then water, and then toxicity, renewable energy, and then circularity indicators are there. All these things comes in EPD. So software, SIMA Pro and Gabi, this is the most widely accepted in industry. And databases like EcoInvent, not only EcoInvent, we have World Steel Database, ULCI, US LCI database, other many databases depending upon our need. So the outcome of the LCA is like EIP, EPD, green claims, and eco labels. So I'll deal about this EPD. So to just to know an overview, like eco labels, we have 3 types of eco labels. One is type 1. It is a voluntary self-declaration, but it's a third-party verified one. Type 1 is the. It can be done for any criteria where the engineering team wants to, like energy efficiency product or energy labeling. All this thing can be of type 1. Type 2 is the self-declaration claim, which is following ISO 14021. I said recycled content we are declaring. So if it is like a third, if we are doing our own assessment and declaring that, it can be under type 2 eco label. And type 3 is the EPD. So the entire life cycle assessment of the product, it's a type 3. So most of this Energy Stars, Green Pro, all these things comes under type 1 eco labels. Type 2 is like whatever the company wants to disclose, because it's not a verified one, self-declared one. So whatever company wants to declare, they can prepare one documentation and submit that to the external stakeholders. So, the third part, I think first I covered about revenue generator. Second, I covered about the SIPC, TM65, the embodied carbon calculator. Third is the LCA I just covered. So the outcome of the LCA is either the impact profile, which we declare ourselves without any third party verification, or an EPD, which is a third party verified one. So first we'll see about this EIP. So here, this is a case study where we have this self-test detector, which has 5 products. 5 SKUs means 5 products. The variance comes in the sensors, like one will be an optical sensor, one will be an optical plus smoke sensor, one will be an optical smoke and temperature sensor. So together. So like that, there will be small product variations on the sensor part. But the overall mechanical assembly, other things are going to be same. Only in the PCB board, the sensors will be variation. So this EIP, this is an EIP self-declared we are giving. Now this is under third-party verification. So before that, we had this self-declared one. So what we did is like, we need to collect the entire life cycle data for this product. So starting from raw materials, transport, we need the data, and this product is manufactured in Lugoj factory in Romania. We need to talk to the engineering team, get the bill of materials for the product, all the life cycle informations like where it is getting procured from the vendors, where it is assembled. So during assembly, what is the raw material, energy consumption, and other things. And then where it is once assembled, to which customer it is moving. So the customers are across US and Europe. So in what mode of transportation it is going. And then at the customer location, how it is getting installed, whether it requires any electricity or water during installation. And then how much maintenance is required during the entire lifespan of the product. So all these things are in forms of data collection. So this is a product information we try to produce. So for any LCA, this functional unit or declared unit is the one which is based on which the inventory inflows and outflows of the system boundary will be accounted. So since most of our products are assembly products, we go for declared unit only. But in case of steel or some generators or some products where they go for functional unit, or even the lights also, like how many hours it can operate, or if it is like a paint, for how many area it can able to. It's not on kg, 1 kg of paint. They won't do for declared. They go for functional, like how much area it can cover, or steel, how much meter, like that. So, but most our products are assembled products. We don't manufacture all parts. We procure from suppliers, we assemble in our factory. So we go for declared unit only, most cases. And declared unit is completely based upon the mass of the product. So we need the mass of the weight of the product with packaging and without packaging, because packaging plays a major role. We know that biogenic carbon is coming from the packaging. And so we need to define the functional declared unit as 1 unit of that sensor with a weight of this much, and for a service life of 12 years. So this 12 years is defined by us, or some standards are there. So I told that there are um, uh, as a part of EPD, we can't do LCA based on only 14040 and 44 principles. We have to comply with something called PCR, product category rules, which is a recipe or a cookbook. It will have all the defined rules and regulations starting from functional unit, how you should define the functional unit, how the system boundary should be taken, how the use phase electricity can be calculated, what is the end of life scenario we can give it to the product. So every product specific or product category rules will be there. If it is like HVAC products, all the HVACs, controllers, everything come into one cookbook. If it is like a fire system, all the fire panels, fire alarms, fire sprinklers, detectors, everything will be aggregated into one cookbook. So we need to follow that for doing our LCA. We can't simply do LCA whatever we wish, like assuming our own. They won't accept for third party verification. So this product follows this EN 15804 PCR, which is a building PCR I told. So they have developed the environmental footprint impact assessment methodology. We have to use that methodology only, and we have to define what are the indicators given in that standard. So that's what we do. So this is about the product. So if you see this product, it will see this product, even though this product is like 140 grams, you see here, sorry, 122 grams. The product weight is just 122 grams only. But if you go into the material breakup of that product will have 200 plus parts, small parts. One mechanical assembly, one LED, one light, one PCB, so many numbers. We can't get every weight of that information. So we make some engineering assumptions there. So you see this product, it has how much components in it. So mass balancing itself is a big task. And knowing that all these informations are available in our internal ERP systems. We can extract this information sitting anywhere. But the values will not mass balance it properly. They won't enter every weight properly because weighing of one capacitor will be like 0.001 milligram or something. They can't weigh it every time and do it, no? So there are a lot of approximations we make. One thing is like we have the convenient in EcoInvent that it has a data sets for printed circuit board assembly surface mounted. So which means that it's a PCB board where all the electronic components are assembled. So that data sets is available. So at least the entire assembly, they can weigh it from the manufacturing location and give us. So that is approximation we are making. So like that, some convenience we are taking because our products are very complex. The weight is very less and the components are more numbers. So that approximations are acceptable. We need to provide the proofs to the verifier. Like how do we do that? In the data quality section, we need to declare. So all these components you see here. Then apart from that, the next you can see the suppliers. This stands for A1 stage, which is the raw material. Then if you go for here, you have the suppliers from different location. You can see China, Denmark, Britain. Every part will have every supplier. And you should know the transportation distance. All this we take from Google only because we can't go and every time measure, no? So at least we know from which country it is transporting through our ERP systems. We calculate the transportation, which is the A2 stage of the product. And then next is the A3 stage. Sorry, next is the electronics. So I told electronics is very difficult. Many components will be there in electronics. So if you see here in the bill of materials, so all these are electronics, R chip, res, capacitor, all these are electronics. So we take an approximation approach here. We calculate only the overall weight of the assembly because it's very difficult. And we should also differentiate what is the active and passive electronics. This is because for the data sets we have in the SEMA Pro, like EcoInvent. EcoInvent will have a generic electronics data set, but to be little more specific, because we can't just throw this is going to be the impact more in the entire product. Electronics will have the highest impact of all the materials. So we differentiate it as like passive or active electronics because every GLP value will change. Passive electronics will have little less when compared with active electronics. So we just classify here. And then next is the A3 raw manufacturing data. So again, I told we can't every product we can't go and do the electricity calculation. No, we allocate for the entire factory for the entire production. So you see here that this particular product is produced in this many numbers for this production year 2024, and these are the overall factory data on water, waste, electricity, natural gas. This we can take it for the overall 1 year, and we try to allocate it to that particular product based upon the number of products produced. So volume based allocation. Then we get this value, allocated value. That should be inputted in the A3 space. Then A4 stage is once we manufacture in our complex, we are transporting to the nearby distributor. We know that information from the ERP systems. So here from Romania to Germany, it is transporting, and then it is distributing to different parts of Europe. So there we take an approximation covering the entire Europe. So that is the transportation to the customer, and in the installation, there is no electricity required for installing this product, this particular product. So we don't have that value. But the product comes with a packaging that will go to end of life in installation stage. Product comes with the packaging to the customer. Then we have to provide some end of life for that packaging, no? Because it is leaving the system boundary. So we allocate end of life modeling for the packaging, which is mostly incineration in that particular A5 stage. Okay, that we have to consider in the model. Then the product goes in use stage where B1 to B5 is the maintenance and the repair. So this product doesn't have any maintenance activity. This information all we need to collect from the engineering team. They will tell this filter has to replace every 6 months or every 1 year. Then if we know that, take that filter value, again add it into your model. Because it is replaced every, say for this 12 years of lifetime, if it is replaced 2 times, if they say, I should add 2 times of that particular filter value into the model again, because that will account also more impacts. So that is the maintenance and repair phase. Then we have the use phase. So this product needs electricity for operation. So as per that PCR, I told no PCR guideline, it's a cookbook for every product, specific products. We have for fire, we have for switches, we have for controllers, HVACs, and then we have for all the electronic products mostly will have this PCR cookbook. We have to follow that rules. So that rule is telling that even though this is a fire detector which is consuming electricity, most of the cases it is on silent mode, quiescent mode. During the fire or alarm stage only, it will need more electricity. Remaining time it's in quiescent stage. If I consider for every entire lifespan, the value will go very high because product is not needing much electricity. Only in the fire state, it needs that peak electricity value. So that cookbook will tell us this, okay, follow this for use phase. So we have to adapt that and find it out the electricity consumption during the use phase of the product. And we need to do it for 12 years because 12 years lifetime I considered. Then, so use phase is completed, product reaches the end of life stage. So end of life stage is divided into C module, which is having 4, C1, C2, C3, C4. So C1 stands for dismantling of the product. If it is a small fire detector, it won't take much electricity into account. Like we can just unscrew it and take it. If it is like a HVAC system, it needs some electricity or some oil or something to be need to dismantle the product from the building. So that should be accounted in C1. So in this case, there is no C1 because it's not manual work. No electricity is consumed. C2 is transport to the end of life facility. So we know this product is used in Europe. So it reaches to the Europe regulations end of life. And the PCR, again, the cookbook, because we don't know. Once we sell to the customer, we are not worried about that. Like we don't know what customer will do. We don't have that trace back. So this cookbook is telling, okay, you can assume a 100-kilometer distance like that. So that assumptions and other criteria, we can follow this cookbook. Now that PCR, which is the product category rule book. So it is telling 100, so we assume 100.
So these rules, they get updated time
Uh, Yeah, so these are like standards, like maybe a 5-year revision or a 10-year revision, it may happen. So most of the products they consider as 100-kilometer only. Some cases they may go for 1,000 depending upon the products. So we have to, because if we go for EPD itself, first question they will ask is what is the PCR you followed? Then only the EPD verifier will do the verification process. We should completely obey or follow that rules and instructions.
This product which is being used in India is sold in India.
This is not sold in India, it's Europe.
So that's all manufactured in this is
Europe only. It's manufactured in Romania, it's used in Europe only. And end of life, everything is in Europe only. But some cases, product manufactured in Europe, sold in US. In that case, you should use the electricity in the US grid, and you should use the end of life scenarios in the US based condition. So in that case, we can't tell. See, sometimes Honeywell will do today in Europe, tomorrow will do in US. So if they want a different scenario, we have to do a different scenario using life cycle assessment. If it is in India, what is the condition? If it is in US, what is the electricity grid we are using? So those things we have to do in our assessments. Maybe scenario analysis, sensitivity analysis, and all you might have learned in the study. So this is where this is playing in a role. So end of life, C3. So C2 is the transportation, I said. C3 is the waste processing, which is the material recovery facility. Product will go to recovery facility. Useful products will be recovered in C3. And then the waste will go into the disposal. That is in the C4. So in our products, I can see that it is made up of ABS, which is a plastic, acrylonitrile butadiene styrene, which is a plastic material, ABS. And it has electronics, fiberglass, paper. So this is a product material makeup. Overall, this product is made up of. Even though it's a fire detector, it has the material composition. Based upon the bill of materials I showed, no, the first page, we have come up with this particular material composition. And this is the weights for everything. And this scenario, so how do I assume this? Again, we have to go for the ISO standard. So there is a standard for electrical electronic products disposal, end of life disposal. It's again an EN standard only. It's European standard. There is no global norms. If you want to do for some global, we have to state that assumptions in our EPD clearly that as per this US based criteria, we have taken this much of recycling, everything to be openly disclosed. So this is again based on standard 50693. I'm using it. So the standard itself is telling, okay, if it is an ABS material in your product, you can take 20% of the recycle credit, 40% of the incineration credit, and again 40% goes to disposal. Say 1 gram if you have in your product, so 0.2 will go for recycling, 0.4 will go for incineration, remaining 0.4 of that mass will go for disposal. This is how you do in the model, in the eco-invent model. And we should calculate how much is the value for everything. We should input all these things in the model. And then finally, module D. I said module D, the benefits and loads that is beyond the system. We are taking the credits for all those things. It should not be accounted with that a life cycle number from starting from A1 to C4. It should be reported separately in the module D. So here in my case, I have a steel in my product. So I'm taking a credit, 80% recycle credit. So that particular emission or that particular life cycle number will be accounted in module D. Again, we have to create one module and put this D value where we have data sets for all these things. If you're taking a steel credit, there is a data set for steel post-consumer post-consumer processing. So this eco-invent has this data set. We just need to plug in that data set into this particular value. It will automatically do the life cycle impact assessment and give you the value. Software will take care of it, but you should know the concept, like how much percent of steel should be taken for recycling in that particular thing. And so these are the benefits of steel recycling. So this is how we prepare our data collection sheet. Once this is ready, modeling is very easy. Just input into the model and connect the correct databases for the inputs and outputs in the system boundary. Then we input this in the model and we run the thing. I told for building products, we have to follow this environmental footprint 3.1 methodology. That's a specific methodology. Why they go for this? Because the characterization factor we define for every environmental indicators is aligned with the environmental like EU regulation. So again, these are basics. Why EPD? It's a competitive differentiation. We have credibility and so EPD and LCA. So I told, so this is a cookbook. For construction product, we have to follow this EN 15804 standard plus A2. This standard is applicable for all the construction product, buildings, raw materials, construction materials, whatever should be following this PCR. And then, so these are the different PCRs I told. So EN15804 is the one which I am talking about, which is the cookbook which has for all the construction products. And if we go for electronics, so in my construction product, Honeywell does for electronics. So we are not doing for steel or other things. If we go for steel or timber or other thing, we need not follow this 50693 standard. Since our products, even though construction coming under electronics category, we have to follow this EN 50693 standard, which is the end of life disposal. We have to follow this for our disposal scenario in our model. And these are program operators. So once we do this, we do the LCA, we convert it in the form of an EPD report. There should be some third party verification. So we call them as program operators. So globally, we have many program operators. So in India, we have this EPD International. So EPD International system. So they are in Sweden also, Norway also, many countries, North America. So they have their own. So these program operators also will be developing some standards based upon this EN 15804 only. They follow that core standard and they prepare their according to their needs. So they will verify our product following that standards. And these are various program operators. So currently Honeywell is doing with this BRE. BRE stands for Building Research Establishment, which is an UK based organization. So they do the verification of our product and publish in a portal called Eco Portal. So Eco Portal is a portal for all the manufacturers and different organizations together. They have for Europe. So our EPD will be published in that Eco Portal and it will be visible to different organizations and stakeholders. So currently we are working with BRE and also EPD International too. In India, we have a verifier called Sunil. He is from SEMA Pro. So we are working with him for another group of, because different kind of EPD operators will give us a flavor like which to approach more or which to go further in our future scales. So these are the standards. So this is a flow I told. So data collection, we have to find the correct PCR for the product, do life cycle assessment, draft that life cycle report. We have to submit to the program operators who are the verifiers and prepare a draft EPD, then third party verification, then it will be published. So it's valid for 5 years. This process alone takes 6 months to 9 months, the entire process flow. So good thing about this EPD is that since we have many products, we can't spend 400 euros for every product. We go for this approach like average approach, representative approach, and worst case approach. So currently what I told is on to the specific product. So we go for bill of materials for that product. We prepare the inventory. We do the life cycle assessment, impact assessment, and submit it, life cycle report. But we have a flexibility on this average product where even though the products vary with a small color or a small sensor, we can group it into one category. Like if we say for a concrete, there are different grades of concrete. We need not do for every product. We can put in an average concrete. This is the mix, design mix, and go for an EPD so that the cost will be reduced. But we have the flexibility to report all that concrete we made, different grades into that report. Following this is the average result of this particular concrete. So the end user, if he can go for 20 grade or 30 grade or anything, he can just pick up that value and provide to the customer. It's an average EPD. It will reduce our cost, efforts, and time. The next thing is like on the representative product. So sometimes there will be a product we need to, sometimes in Honeywell case, we can't go with an average. We can go with an average, but we take this representative approach, which means that we know which product is sold most in numbers, production numbers, which product is more, taking that product as a representative, do an life cycle assessment for the product and do an EPD for that product and submit to the verifier. So that product will cover multiple products into the same family. So, but before taking this approach, we should follow these 3 guidelines, which is given here. The product should be made from the same company and it should follow the same production process. because manufacturing electricity will vary. So it should follow the same production process or assembly process. Third thing is it should be on the same product category rule. So for fire alarms means it should follow fire. One for controllers, one for fire. I can't do that thing in this average or representative approach. So the last one is worst case product. So sometimes the company may not be able to differentiate the numbers, which is maybe many products are in the same numbers. In that case, they go for worst case. Worst case is like they are declaring the product which is having the highest environmental impact, so that the product in the list of products, even the lowest impact will not affect much. So they are declaring the highest environmental impact product, which is having highest GWP value and which is having highest chemical compliance, chemical substances into it. So which means that we declare the highest or a conservative thing so that all our products are within that range only. So for that approach, they are doing this worst case approach. So most of the valves or lightings, this and all go by this approach because they won't vary much in the metal composition. Metal composition, if you say a valve, it is made up of brass. There will be some additional coatings or some color changes or which is not going to affect our LCA value. So they can go by this approach. So this is the flexibility in EPD where manufacturer need not spend so much money on verifying or doing. It's not only money we need to do for LCA for all the models. Collect data sheets for all these models, mass balance it. So instead, choose the correct representative or correct worst case product, do LCA and provide the proper justification in the EPD report. So doing LCA is like we know, but from the verification point of view, they expect more onto the evidences, like how we collect the data, how we are assuming in the model, what are the scenarios we are taking. So they need that proofs to be submitted along with that. So that is the best thing here. So that's what, see specific product, average product, representative, you can see here one EPD covers 13 variants. This is an average based one. So this only one EPD will be done or only one LCA will be done, which covers 13 variants like different carpets, different colors, kind of thing. Okay. And here you see representative. So here in this, it's a lighting product which has 13 variants covered in one thing based upon the highest production number they have taken and done the EPD. So in all these cases, we should be careful that the variation in the GWP value should not be more than 10%. Because if the material composition is completely varying, there will be more than 10% variation will be there in the output. So we need to provide that proof also to the verifier that this product is less than GWP value. So that only it can be grouped as an representative or a worst case product scenarios. And here another one example. So this is like a good example for an electronic products grouping. So you see here this particular circuit breaker, it has 511 variants, 511 products, but they do only one LCA and one EPD. And we have to provide, there is a process called extrapolation rules. So we can do EPD for LCA for one product and extrapolate to the entire product family. We need to identify that particular parameter. So in this case, weight of the product was the factor which is going to change between the products. That is one extrapolation factor they are doing. Second is average power loss, because all the circuit breakers will have different power ratings. One will be 28 volt, one will be 50 volt. So based upon the power ratings is a second extrapolation factor. When they do this, first we need to identify one representative product and then identify this mass based or power based extrapolation, and then we have to do a sensitivity analysis. How variation of this parameter will affect the entire group. The variation is not much or less than 10% is acceptable. So, and then we need to define this extrapolation rule also, because the end user, so here we declare results for only one product, but the end user wants to know for 511 products how they will do is based on the extrapolation table we are giving to the end user. Like what is the variation in the sensitivity analysis. So this is a first EPD for Honeywell published recently, and where I am the LCA practitioner for for this particular product. So similar to the previous product only, like SR, which I told is a smoke detector. This is another brand called Gent. This brand is called Gent. So this product EPD, it's a product specific EPD which has 11 variants. So the specialty of this product is as per the fire standards, every 6 months the fire alarm needs to be tested. Otherwise, it will give a lot of false alarms or some maintenance need to be done based on the fire standards. So a person traveling to a building, testing for more than, if it is like a 20-story building, it will have some 3,000, 4,000 fire detectors into the building. Doing manual testing of all those things will take lot or 1 week of time for a person to go there, stay there. So all this contributes to the scope to emissions, because it's the emission, the person traveling from company going to the customer, doing that emissions and other things. So in order to reduce that, uh, we worked with that vendor of the building and developed this self test. So which means that, so here, so this particular self test, what it will do is, so this is the claim. So what it do is, it has a Bluetooth module into this is the product design we changed. It's a Bluetooth module into it. It will connect to this application. Through the application, the electrician or technician can connect multiple fire detectors into his system and just put a trigger button. It will have automatic trigger of the smoke as well as the heat. Thermistor is placed inside it, as well as the smoke injection system is kept into it. That is the patented technology that Honeywell do in this particular product. And they trigger it, and within fraction of second, it will automatically test and it will provide you the report also. So that the manual person visiting, taking time and emissions, everything is getting reduced. So that's what they want this product to be, an EPD product. It's a high runner in the US, Europe market. So they wanted EPD. So because competitors are also developing this. So with this technology, we are able to reduce 86% of the man hours, persons going there and wasting their time on testing each and every product. And also they could avoid like 3,490. So how this value comes? So that's where this LCA plays a major role. I'm telling in some numbers. So we need to collect data from the site on so this is based upon the persons, like how many persons, how many staying, what mode of vehicle transport he is going, how much distance he is covering. All this informations we need from the project team. And we have the similar data sets in our eco-invent. We try to replicate that and do this kind of green claims. So this is a claim we are making. So using this product is able to reduce like 3490 kg CO2 emissions in the entire 12 years of the product life cycle. So that is a claim we are coming out of this life cycle assessment. So we have not targeted onto the electricity part of the app. We are only targeting only on the person's visit. So how many days he's travel in that particular, it's a case study based on UK buildings. So you can see it's an UK based case study. It is based upon a building. It's based on 426 optical detectors into that building. So the realistic data we get and try to do it in the model and see how much emissions we are able to save using this technology. Because a normal time it takes around like 7 hours of a person, whereas using this Bluetooth like half an hour he could able to do. So we are able to do that in the model and give this claim or based upon the life cycle assessment. So not only in this, we have another one claim also we made. I've not shown here. So most of the products comes with an instruction manual. So the product is 200 grams. The manual it's 1 kg. So if you try to reduce that, it will save your carbon emissions. So the team comes to us for a QR code based label. So they prepared a QR code where if you scan it, the manual will come automatically in the to you. So this reduces lot of savings in the paper. So they ask how much carbon savings happened because of this. So again, we did a analysis of the data they provided, and we do the life cycle assessment based on the particular region, like what data sets to choose. So it should be geography specific also. So the data quality is very much important in life cycle assessment or EPD. I should choose the appropriate Europe one. I cannot just go to Indian database and do it because lot of variations will be there. Europe has mostly green grids. In India, we don't have. Um so we have to take that assumptions, and also technology, time, all these things are important. This is another outcome of that um, life cycle assessment only again. Then this is another one project on eco design. So here we have a power supply unit. So the project team, they wanted to do a material reduction, weight reduction in the product. Say if you see the legacy product, which is 1 mm thickness of this enclosure, has 5.6 kg, 5.7 kg close. But they wanted a new design in the product, which is having 4.6 kg of steel only. It's a steel enclosure for the power supply unit. So this is an eco design, like there is a material reduction or material weight reduction. So because of that, how much carbon saving we are able to make. So that is the claim or eco design we are targeting in this product. So again, we collected the informations. So in this case, I have not considered use phase into account because product is almost same. And only if you see here, the raw material, manufacturing is same because both the products are same only. In the raw material, like the product with the 0.7 mm thickness, it's 9.07, whereas 0.1 mm thickness is 1.24. The raw material is little high, so the impacts are little high in the GWP value. And based on this carbon saving of 3.6365 kg, we are able to obtain from this small change of thickness of the material. So that is a eco design we are trying it. So this is for weight reduction. We can even think for life extension of the product. Say if you replace some parts, another 10 years of the lifetime will be extended. So will be in future, like we are planning. So that can be evaluated using life cycle assessment, like how much we can save by changing one part and extending the life of the product. So this is the EPD. It is more or less similar only, like it's 11 variants covering the entire life cycle. And it's not only we need to do EPD for our on all the products. Here you can see it's a vendor EPD because some of the products, what Honeywell do is we buy the product, brand it with Honeywell, sell it to the market. Just a branded products, not own manufactured products. In that case, our vendor will do EPD for us. So the suppliers for that particular product. Here is a valve. So it's a PICV valve. It's a pressure independent control valve. So this valve EPD, the vendor has done EPD for us. So since this is a metal, mostly of the metal based or brass based, they could able to combine, I think around 14 products into this one EPD with a average approach. Like we can take an average 1 kg. So the functional unit of this, sorry, not the functional unit, declared unit of this product EPD is 1 kg of that valve. So based on that, they did the life cycle assessment and EPD. And this is a green climb, and this is eco design. So since some of the EPDs we are not going outside, we are self-declaring. So what at the end we try to do is we benchmark with some competitors because we are doing assessments, but how far we are environmental friendly or how eco-friendly, we always benchmark with the competitors or what is in the literature or things. So here these Apollo, Schneider, these are competitors for our Honeywell in this electrical electronic products category. And we try to benchmark. So you can see here. So one good thing in this PCR is that we can do one comparison of the product, even though because everybody follow the same cookbook rules. They can't deviate from the cookbooks. See, you will do LCA in different function unit. I will do LCA in different function. The values may change. But if you go for EPD, the PCR rules are there. Everybody should follow that. So in that case, benchmarking of our product with the competitors is easy because they are apple to apple comparisons. And so by this, we can say that our EPD is slightly higher than Schneider, but close to Apollo. So we are on to the market, like a similar number. So this benchmarking helps in something like EU taxonomy, where we need to benchmark our product with the available in the market to tell that our product is more sustainable or more environmental friendly or not. So that declaration should be given for the EU taxonomy regulation. So this benchmarking activity supports us. So you can see the variation of the tools I told, like revenue based, SIPC, TM65, and different routes. So we just made a comparison of all the things here, like the same product compared for different tools. So you could see SIPC basic, which is giving 4.14 kg, whereas mid-level is we are taking manufacturing electricity into account. So little robustness are there. So we have 3.27 kg. This is a Gabby software doing the same assessment, and SEMA Pro. And BRE Lina is a tool developed by SEMA Pro. For building EPDs, they develop a tool. So using that methodology, so we could get almost very closer value. So which means that the software parts are more accurate because assumption approximations are neglected. We are taking the exact geography, exact location, transportation, everything into account. So we always try to benchmark with the market. And so basic is considering only the raw material impacts. The manufacturing, the A3 stage is not accounted. So mid-level is like it considers manufacturing impacts also in account. Yeah, it should be lower only because basic is lot of assumptions they are taking. Only the raw material and manufacturing end of life is completely assumption based. They are taking some 10% assumptions. But if you go to mid level, it is like exact production numbers we are putting. And in some cases, if you don't have that information, basic itself they are taking into, it's acceptable in the market. So EPD challenges, data availability and quality, which is very much important. So collecting data is very challenging. We have to make many approximations and allocations based upon our need, like electricity allocation, mass-based allocation we can do. And then dynamic nature and impact assessment also, certain limitations are there. And time and cost, all these are challenges in EPD. So in like standardization. So some standards, for example, Euro targets follow EN 15804 standard. If you want for global product, again you have to comply with another standard called EN 21930 because that is global. This is more Euro specific. If your product is in both the market, you have to comply both the standards for your EPD. So like that, standardization things are there. In verification, it's time consuming and lot of things. And then market acceptance and scope and boundaries. So what to include in the end of life scenarios is again one challenge. As a practitioner, you will assume something on your EPD, I will assume something on your EPD, which should be transparently communicated. See, in this case, electronic products, we can simply tell 50693 standard we are following. But some people won't follow that. They will tell, is it realistic in the market? Say, for example, the standard says 80% of the steel can be recovered, but it is not. It can be more also, it can be less also. It is realistic in the market. So in that case, you can make your own assumption, but you have to state it from where did you assume, or from directly from the processing facility. If you have that information, you have to state everything to the verifier. And sometimes the product comes with recycled material into it. For example, steel. If you see steel, all steel materials are not virgin. Steel will be used having some kind of scrap value. They will manufacture an electric arc furnace into a new steel product. In that case, if you know what is the recycled content of the scrap into the new product, if you have that value from the supplier, you can do it in the model so that your emissions will come down because you're using the recycled material again to produce a new material. So the raw material and transportation impacts, manufacturing impacts, A1 to A3 is already neglected because you have the final product into account. So if you have that value, that is added advantage to reduce your life cycle number. And if you go for green electricity grid in your factories, it will reduce your manufacturing emissions. And electronics, these are the major contributors. So go for some ICs which have a less impact. That is the eco design part. If we have some ICs or some electronics which has a less environmental impact into our product, that will reduce your emissions. And also from suppliers. Sometimes supply chain emissions will be very, very high. Say, for example, in Honeywell, in Lugoj factory, we source one particular item on electronic from China, which is like almost 6,000 kilometers. So we know that there is a huge supply chain emissions. So we can trace back that and look for local supplier for the same product so that our emissions in the transportation front will come down. And in the use phase, only the design, the electronics design, we have to choose in such a way that our product consumes less electricity. So that is the way we can do in the use phase and end of life. So now design is going on that um, can be easily dismantled as separate parts, because if parts are mixed together, we can't separate it and recycle or get the credits. Say, for example, some electronics will be integrated with the plastics. It is very difficult to separate both in the processing facility. So the design, if we do some small design alterations so that it can be easily separated out, that will increase your value in the end of life. Also, the extended life of the product. Replacing some, say for example, some ICs keep on replacing in your product. ICs get damaged. If you try to change only the IC, the product works. In that case, small maintenance will save the second life of the product and save the energy emissions or the entire life cycle. So those are some thoughts in eco design which we are planning for the next set of studies in the coming year. So this EPD, PCF, recycled content, everything will be going on as usual because we have a huge product portfolio. We need to declare numbers for all the products. So that will be going on. But in addition to that, how we can make it different in the market is like eco design. Taking some projects on digital product passports. So in 2028, the regulation is going to come. So we need to prepare ourselves now itself for the digital product passport. And EU taxonomy is also going to come in 2028. So to comply that, how we can make it more sustainable. So that's our next year plan.